Hi Fiserv, I'm Dhyan.
And I'm Shash.
I'm Mayookh.
And MN.
And
we're Team Titans.
And today we're excited to introduce our secure biometric payment system built for the future of fintech, BioPay.
Our solution uses encrypted and segmented fingerprint data to authenticate payments without ever exposing a full biometric identity.
Here's how we approach the problem and how this technology fits perfectly with Fiserv's role in financial innovation.
Today's digital payments rely on passwords, PINs, and physical cards, all of which can be stolen or compromised. Biometrics should solve this, but most systems still store or transmit full fingerprints, creating major privacy and identity theft risks. We wanted a system where users can authenticate with a fingerprint without ever sending or storing the actual fingerprint. Our goal is to create a payment method that is fast, secure, and impossible to reconstruct even if data is intercepted.
Before arriving at our final design, we explored multiple concepts: storing fingerprints locally, capturing and transmitting entire fingerprint images, facial recognition kiosks, and a biometric credit card hybrid. But each one of these had problems, either too risky, too expensive, or not scalable for fintech infrastructure. So, we shifted towards a segmented, encrypted, partial biometric model where no full fingerprint is ever revealed. That decision became the foundation of our prototype.
We then expanded on this decision and general idea as said before and moved to the next step of the design thinking process, defining. We created a flowchart that would explain on a high level how the entire procedure of this will work. In the green, the user will start the enrollment and all the minor details are present, and the Fiserv account enrollment will start in the red. Next, when the user starts and decides to pay using BioPay, they will go to the terminal, scan all of their groceries or items, and then a fingerprint slicer function will happen, which we will talk more in detail, and as well as the Fiserv biometric check afterwards with the fingerprint and BioPay system we have.
Here's how our solution works. When a customer decides to enroll their fingerprint with Fiserv and BioPay, at any payment terminal that is capable with BioPay, they must link their bank account details, specifically their bank UUID or other identifiers with compatible banks, as well as scan their fingerprint. After, the terminal will post a bank ID and a fingerprint hash.
In our program on the right, the sensor gives us a 512-byte template of a fingerprint. Instead of storing or transmitting that directly, we compress it into a 256-bit locality-sensitive hash. For each output bit, we randomly sample multiple of those from the template and use majority voting to determine its value. Because the sampling is deterministic, the same fingerprint produces the same hash, but small variations don't drastically change it. This gives us a compact, non-reversible representation of our fingerprint that is suitable for fast similarity matching. After the creation of the representation of the fingerprint, that hash is sent with the user label to a server. The server stores it and inserts it into a JSON index for fast homing distance matching later. It does so by using this Python function on the right to write to that file.
Remember that this fingerprint isn't actually their exact template, but a numerical version of it used specifically with BioPay and a template that cannot be unencrypted. Next, when the user decides to pay using BioPay, they scan all their items and during the checkout process, scan their fingerprint. Then, this fingerprint is divided into a grid of 6 by 6, and 5 selections are selected based on most detail and hashed together.
Here, the program on the right divides the hash into 36 sections and chooses 5 based on the best fingerprint detail.
This is then sent along with the transaction time and merchant ID to ensure that the transmission isn't phony. Then the server with BioPay will use FAISS, or Facebook AI Similarity Search, to compare the partial data against a secure biometric index full of everyone else's fingerprint hashes. Then, FAISS returns a matched UID, or user identity, which enables the payment and starts to communicate with the bank to finalize the transaction. Since only 5 out of 36 hash fragments are transmitted, even if someone intercepted them, they couldn't reconstruct anything meaningful. Nothing is stored locally, nothing exposed to full fingerprint, and every transaction uses a slightly different combination of segments for added security, as well as the time and the merchant UUID.
Fiserv already processes global payments and identity validations at massive scale. Our server-side authentication model fits directly into that ecosystem, allowing Fiserv to host and manage the biometric matching service as a secure financial identity platform. Two fintech careers closely connected to our project are cybersecurity analyst and machine learning engineer. For cybersecurity analysts, they ensure encryption, secure data transmission, threat modeling, and privacy protection on core elements of our segmented biometric system. For machine learning engineer, they design fast, scalable matching algorithms like FAISS that can authenticate millions of users using partial encrypted biometric signatures. Our solution demonstrates how these careers directly drive fintech innovation.
Our prototype uses an ESP32 Wi-Fi microcontroller, a fingerprint sensor, a Python backend server, the FAISS similarity search algorithm, and encrypted Wi-Fi communication. And some challenges we face are maintaining accurate matches with only 5 fingerprint segments out of the total 36, implementing consistent hashing that preserves unique biometric features, ensuring Wi-Fi security on lightweight hardware, and optimizing FAISS for partial biometric comparison. Each challenge pushed us to engineer a solution that's both secure and scalable.
Our biometric payment system allows users to authenticate quickly and securely without ever exposing their full biometric identity.
It's private, reliable, and designed for real-world fintech deployment.
We're excited to help shape the next generation of secure digital payment.
Thank you, Fiserv.